Hey there, let's talk about soil texture as it relates to all the physical properties of soil. There's a lot to discover when we are investigating soil physical properties, and texture and structure are two of the big ones, the ones that are easy to test for and that have a large impact on how you grow plants. Let's take a look now at our soil physical properties. As we have discussed, healthy soil is composed of several different types of ingredients, and what we think of as dirt is typically the mineral components of the soil. But we know that there's organic components of the soil as well, and there's empty space, the gaps. And those gaps should be filled with air plus water. So in a healthy soil, the ideal ratio would be 50% space. And in that space, it's an even mixture of air and water, 25%, 25%. The other 50%, the solid stuff, up to 5% of that should be organic matter or living in a healthy soil. So it's not all compost and it's not all sand and dirt, but we need both. And we need those to be mixed properly. And you can add a ton of organic matter, but you're still probably only going to be in that 5% range. It's actually hard to add a lot of material to compensate for the amount of minerals. We need those minerals. Those are good. Those have nutrients for our plants. And so how those minerals are arranged is what makes up the physical properties of soil. There's three main classifications for soil size, the particle size. And we break them down, so we call them separates, because we separate them out into three different categories. And those three categories are sand, silt, and clay. So you may hear about people saying, oh, I've got a clay soil or I have a sandy soil. In fact, everybody knows what sand is because it's in the playgrounds and on the beaches. But all it really is a size of a particle. It doesn't matter what the particle is made out of. It could be quartz or silica, or it could be other minerals that are in that particle. This is just a size classification. And there's an illustration here for comparison that shows you the sand goes from anything from 2 millimeters to 0.05 millimeters, which is very small. All of that is sand. Once you get below 0.05 millimeters, we are in silt category. That goes all the way down to 0.002. And so it's so small that it's very difficult for you to even see one particle. Once you get into the clay category, it's so tiny you cannot see it with your eyes. You can see a bunch of clay put together, but you cannot see an individual clay particle. And that is the smallest. So sand is the biggest, clay is the smallest. And your soil likely has some combination of all three, and we call that a loam. Loam just means it's a mixture or a blend of three different types of soil separates. If you go bigger than 2 millimeters, you get into gravel. So you've also probably heard about gravel, little rocks. You put it on the surface of the road. Gravel does not count as soil because plants do not grow in gravel. They may grow through the gravel because they're rooted in the soil below. But once the particles get so big, more than 2 millimeters, they're no longer able to hold the water in that pore space. And so then they become gravel, and from up there, there's other classifications. But the ones we call soil are sand, silt, and clay. Sandy soil is the biggest in particle size. So therefore, we can have some expected results. And so we will have large, open, pore spaces. We will have good aeration for plant roots, excellent drainage. On the other hand, it'll tend to dry out more quickly and may often be lacking in nutrients because as the water flushes through, it will pull the soluble nutrients away from the rocks. So you may lack mineral nutrients in sandy soil. This is good for plant growth as long as you add some kind of fertilizer, and it could be a soil amendment. Organic matter is a great addition because it helps to deal with some of the limitations of sandy soil. But in general, sandy soil is excellent to grow in. On the other hand, you have clay soil. Clay soil is also not too bad to grow in, but you need to treat it properly. So in this case, we have small, numerous pore spaces. And so because it's so small, lack of large spaces, aeration is the problem. Drainage is the problem. So this soil holds water very well, becomes saturated quite easily. And so the clay hangs on to the water, which can be a good thing because you need your water to hang out in the root zone of the plants. So clay is not all bad. It's just that we need to know how to balance the limitations. If you have a clay soil, it will tend to hold nutrients better because there is less leaching. There's also an electrical property that causes the ions to hang on to the particles, which we'll talk about in a few weeks. But it can be difficult to manage because it's so heavy and it sticks together. And when it does get wet, it might stay soggy and you need to not walk on it and you have compaction problems, you have runoff problems. Interestingly enough, the best way to amend your clay soil is also with organic matter. Now, if you have sand, you don't add clay. If you have clay, you don't add sand because when you do that, you make a brick, you make adobe or concrete, and you don't want to do that. Adding the organic matter is nature's way of improving the soil structure. So when we have a blend of small, medium, and large particles, we call that loam. And so this is kind of like the Goldilocks. It's just right. It's not too large, not too small, not too wet, not too dry. It's kind of right in the middle. So that's considered to be the best kind of soil is a loam. In fact, a sandy loam is what a lot of people would prefer to have if they had their ultimate choice, a little on the sandy side. Loam has good drainage, good aeration, and a good water and air balance. So it's considered to be the best of all soil textures. But again, we can always add the organic matter and it helps to improve the structure of the soil. So anytime you have three things, if you were to make a spectrum, instead of just going between 2 points on a line, we're going between 3 points, and that makes a triangle. So in this case, we call it the soil texture triangle, and it's a balance between percentages of sand, silt, and clay. I'll give you some assignments that you'll work through to practice operating with this soil textural triangle, but it's a way to classify your soil in a texture type based on the percentage breakdown of your three classifications. And so when you just look at it, it looks a little bit crazy, but for now, just consider no matter what, if you're somewhere between 100% sand, silt, or clay, you're going to be in this triangle somewhere. I'm going to show you how to classify yourself on that triangle. How do we know what the percentage is? Well, there's a couple different ways to test. And one of the most common is the soil jar test, the texture jar test, mason jar test. People call it all kinds of things. It's not the best way to test, but it's one of the most common ways to test. So you'll be doing this yourself. Take your soil, put it in a jar of water, shake it up, and let it separate out because the heavy stuff falls first and the light stuff falls later, sometimes 48 hours later. So you can see here, it's actually quite difficult to measure because it's not necessarily a line between all of these, it's just a gradient. And so in this case, the image on the left, you can see sand, silt, and clay are labeled. And the clay is pretty easy to distinguish, but that could be part silt, to be honest. And so the image on the right is attempting to come up with a percentage breakdown. But again, based on visual characteristics, it can be tricky to be very accurate with this method. So we're going to have you test with this method and see what your percentage breakdown is, and therefore what texture class you're in. But then we're going to combine it with this next one, which is a little bit, it seems like it should be less scientific, but it actually is more accurate because you use your hands, and your hands are very good at determining different types of feel, different textures. So you take your soil sample and you follow this wonderful flow chart. And basically, if it can make a ball, you know you're not in sandy soil. If you can make a little snake or a ribbon, then you know you've got some clay. And then based on how gritty or smooth it is when you wet it down, you can tell if you are a sandy clay or a loam or a silty clay loam. Put yourself in all the different categories. So you're also going to do this texture by feel test. Now that's the texture, and a lot of people get really obsessed with their texture. They say, I've got clay soil, so I need to do this, or I have sandy soil, so I need to do that. But the truth is, whatever you have, that's not really the main consideration, because you are going to have a texture of some type, and that texture will have certain properties. But you can amend with organic matter and you can try to balance everything out. But there are some other things to consider when it comes to the physical arrangement of your soil, because this can be arranged in many ways. And so once you get all these particles pressed together and compressed with time and geology, you may find you've got some good arrangements or some not so good arrangements to consider. And if you've got difficult structure, that's what we call it, that is the thing that's going to affect you in greater detail. It's important to know the difference between texture and structure. Texture is how much sand, silt, and clay do you have, but the structure is how are they arranged in physical space. So we're going to go through this and take a look at the different types of soil structure as well. In nature, these textures, these different particles, they form groups or clumps, and we call them aggregates. If they're natural, we call them PEDs, P-E-D. So in nature, it forms PEDs. You've probably, as a kid, picked up a ball of soil and you thought it was a rock, and then you tried to break it, and it's an aggregate. It is a clump of soil. Technically, so if we want to stick with terminology, the PEDs are naturally derived. If humans create them, they're called clods. So a dirt clod is a aggregate. It's a group of soil that was human-made. A natural one is called a PED. So we have PEDs and clods. They're both aggregates. Now here is a drawing as well as a diagram of an aggregate up close. So as we can see, aggregates are granules that are made up of many soil separates bounded or glued together by the organic matter. So take a look at that painting on the right-hand side with the different colors and the roots. It's actually even showing you bacteria and fungal hyphae in there as well. It's holding all those particles together. And it's when you hold those particles together that you get water to exist inside the micropore spaces. Inside that water is where the life is going to be. And so this is vital to your plant health. You can see large pieces of sand, small pieces of silt, but it's how they are glued together with the presence of organic matter that really makes the difference. So here is a rundown of various types of soil structure. The first one we'll cover is the primo. It's the kind you want. It's called granular. So these are small aggregates, clod-like, and they look like cookie crumbs, or they almost look like chocolate cake. It's very crumbly. And if you take one of those aggregates and break it, it'll break down into another smaller aggregate that's the same size, kind of a fractal pattern. It just keeps breaking up, but it always has this same roundish crumb-like structure. That is ideal, and that's what you want to have in your surface horizons or your topsoil where your roots are going to be growing primarily. You can also have vertical columns, or in this case, prisms. You end up with, because of the mineral content of your soil, you end up with general patterns on how they get arranged. And you can get columnar, tall aggregates that they can be prismatic in shape. So they've got sides and they're kind of angular. Usually this would be found down in the subsoil layers, lower horizons, but it is pretty distinct and easy to find when you've got it. And you can imagine that has an impact on how things flow, especially vertically, if you've got gaps that are going up and down in the soil column. Another typical subsoil, or typically a poor soil structure, is known as blocky. So if you've dug deep and you've reached a layer where there's not good structure, you found these large clumps, and we call that blocky soil structure. And they can even be kind of straight on their sides, almost like dice or like cubes. And these are larger than the crumb structure or the granular structure, so large that they're outside of really what soil should be, and it kind of starts to look like gravel or like rocks on the surface of the soil. And so this can be a difficult structure to work with. A lot of times, especially with clay or anything that was deposited over time, you end up with a platy horizontal structure. Some people actually call this platy, but I think of it like a stack of plates. So I say platy structure. And these are thin, flat, horizontally arranged layers of soil. And this is common in compacted soil. And if you compact the soil, you're not necessarily going to make this. But what will happen is, if this is naturally present, that soil is going to be very compact. And it's also going to be difficult because as water flows, it's going to tend to run off instead of go down. So this platy structure is another difficult one for you to have to work with. Here is similar to the prismatic, but we've got columnar. So if it's rounded, then it's called columnar, less angled than the prismatic. And depending on where these are, you may even find some places with harsh soils that those caps, those tops of the columns, the surface of the soil can even be a little bit rounded and domed. You end up with, especially in like desert soils, this kind of a consideration. And you end up with salt buildup in these columnar soils. So if you are just going to a new place that's never been cultivated and you see this columnar soil structure, it may be an indication of what the climate is like, or what the mineral component is like in the soil. And then you've got what's called a singular structure, or you could think of it as like no structure. There's no bonding and everything is just pulled apart. There's no aggregates. And so this would be a singular soil structure, and also not you think, oh, it's great because it's nice and loose. But no, that's not good because it's going to wash away if you irrigate, and it's going to blow away in the wind. And also, there's not a lot of uh, organic matter, most likely, to help bind this soil together. So it's kind of like a sand dune, but it could be made up of clay as well. So this is called structureless soil. And if you've ever had chickens, you let the chickens stay in the same piece of dirt for a long time, you'll end up with soil that looks like the surface of the moon. It's just kind of dusty and like craters and stuff. And that ends up with this singular structure. You may have really great soil, but if you let animals graze on your soil too much, they destroy the soil structure and they leave it with this singular form. I've also seen this in pure clay soil where there's too many rabbits overgrazing. Even in wild spaces, you see kind of like a loose dust on the surface of the soil. That's because it's been compacted and been ripped up and been broken down by animals. And they leave this singular or this loose soil, which you need to do something to help bring it back to its aggregate form. You need to add organic matter. And then finally, there's massive, which is larger than blocky, but it's just these giant clumps of soil, typically clay, and it results in kind of a sealed off layer where water does not penetrate and not a whole lot of oxygen is present. So this is also a structureless soil, but it's just one solid basketball-sized chunk of rocks. So this is your massive soil structure. And it can be hard to break apart very large clods when you till or turn the soil. And so you need to be mindful of selecting this type of soil in the first place if you're going to grow on top of it. And if you have it, you have to try to have nature help you to rebuild it. A lot of times you'll have this down in the subsoil, and you'll have a different type of structure in the top soil. The really big clods, that's called massive. Now here's a little table that's showing you the positives and the negatives, the good ones and the bad ones. And it's not 100% good or 100% bad. It's just that some are easier to work with than others. So the ones on the good side is that granular structure. That's the primo. That's the one you should try to cultivate and develop. And prismatic and columnar are also okay because they will at least have good vertical drainage and water can go down. And a sandy structure or a granular structure, you could bring that back with the additions of organic matter. On the negative side, the blocky, the platy, or the massive. Those are ones that are going to be difficult to grow in no matter what you do. And so you could try to till or plow, or you can add some amendments, organic matter and others that will help to form natural aggregates. But if you don't address the soil structure and you've got one of those three, it's going to be very difficult for you to grow your plants. So there we go. I hope you found that to be informative. It develops our understanding of the physical components of soil. There are many other physical components of soil, but the two here we're talking about, texture and structure, are very important to understand how they are defined, understand how they are determined, to be able to recognize them when you see them and to measure them for yourself. Because what comes next is a whole bunch of different management decisions based on the texture and structure that you inherit. Remember, you don't change your structure. You don't add the sand if you've got clay. Whatever you've got, that's what you got. But we can work with it along with natural processes to try to make that soil work for us as opposed to work against us.